So here are solutions to the Desmos activity for generating a power series. So we need to generate a power series for 1 over 1 minus x cubed and find the interval of convergence. So, we know the power series for 1 over 1 minus x is 1 plus x squared plus x cubed and all the way out plus x to the n plus dot dot dot. So we're using this pattern to generate our power series for this example here. And you want to think about this as 1 over 1 minus something. And then we have 1 plus that something squared plus that something cubed and so forth. So 1 over 1 minus x cubed is 1 over, again, 1 minus something. So 1 plus that something squared plus that something cubed and so forth all the way out to plus that something to the nth power. And of course we could rewrite this as 1 plus x cubed plus x to the 6th plus x to the 9th plus dot 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 plus x to the 3n and so forth on down the line. And now to find the interval of convergence, we just have to realize that this is a geometric series. And the common ratio is x cubed, and so geometric series will converge when the magnitude of the common ratio is less than 1. That happens to be when just the magnitude of x is less than 1 as well. And the nice thing about a geometric series is we know that the series diverges at 1 and -1, so I don't have to worry about checking the endpoints on this one like I would if I was using the ratio test. So the interval of convergence is going to be the open interval from -1 to 1. And by the way, this is going to be our f of x here, only when x is in this interval here. So for values of x in here, the answer is that's the power series valid only between -1 and 1. All right, so same idea, except we have a little bit of algebra to do here first. So I'm going to do some factoring in the denominator here and get this expression. And then I'll do a little more algebra just to make sure it's clear exactly how I'm thinking about this. All right, now that we have this structure here, so we're going to have 1/4 times. And so here we still have our 1 minus something. So this is going to be 1 plus something plus that something squared plus that something cubed and so forth on down to that something raised to the, raised to the nth power and so forth. We'll do some more algebra to this, so don't panic yet. I'll tell you when it's appropriate to panic. We don't need to panic. This stuff is going to be easy. If we do some simplifying here, which we don't really have to do, but that's going to be x to the 4th over 16 minus x to the 6th over 4 cubed is 64 plus dot 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 plus. Now I'm going to separate out the negative and make that -1 to the nth power, x to the 2n, and then all of that divided by 4 to the nth plus dot dot dot. And then I'm going to distribute the 1/4 here, so you get 1/4 minus x squared over 16 plus x to the 4th over, I said 16, I wrote 64, didn't I? Interesting. Okay. And then minus x to the 6th over 256 plus dot 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 plus -1 to the n, that doesn't change. X to the 2n doesn't change. 4 times 4 to the n is going to be 4 to the n plus 1 plus dot dot dot. So this is our power series for that expression. We still have a geometric power series. Our common ratio is the opposite of this x squared over 4. That's what we keep multiplying by each time. And we need the magnitude of that to be less than 1. And which means the magnitude of x squared over 4 is going to be less than 1, or the magnitude of x squared is going to be less than 4. And so we take square roots, we're going to get negative 2 less than x less than 2. And so that's going to be our interval of convergence, negative 2 to 2. Okay, on to the next one. So again, x over 4x plus 1, we're going to do a little bit of rewrite. So this is going to be x times 1 over 1 plus 4x. So I'm just trying to make it look like the same structure, at least a little bit. Or you can even think of this as x times 1 over 1 minus negative 4x. 1 over 1 minus something. We're going to multiply by x. So our function f of x, this is going to be x times 1 plus that something squared plus that something cubed plus dot 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 that something to the nth power and so forth. So 1 minus 4x plus 16x squared minus 64x cubed plus dot 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 plus, and again I'm going to separate out the negative 1 to the n, 4 to the n, x to the n plus dot dot dot, and then I'm going to distribute the x, so x minus 4x squared plus 16x cubed minus 64x to the fourth plus dot 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 plus negative 1 to the n, 4 to the n, x to the n plus 1 plus dot dot dot. Now in the Desmos activity, you needed on the next screen after you're supposed to work this out, you were supposed to type in the expression into the summation that would generate the terms of the power series so that you could see if you did it correctly. As you add more and more terms, you could see if the graphs were matching up. This is what you're supposed to enter into that expression. And if you didn't, provided I have not paused the Desmos activity, you can go type this in and see that it will work. All right, so again, because this is geometric, we're multiplying by the same thing each time. We're multiplying by negative 4x squared. So we need magnitude of negative 4x squared less than 1. And so that would be 4 times the magnitude of x squared less than 1. And so the magnitude of x squared is going to be less than 1/4. Or, take a square root here. You're getting a negative 1/2 less than x less than 1/2. That is your interval of convergence. All right, so for this one, it says to use differentiation to generate a power series for this. And so you have to make a connection here between some power series that you know the expression for and this function here, or that function for that power series, and how to differentiate. And the one we're talking about here is, let's point out, if we take the derivative of 1 over 1 plus x with respect to x, then we end up with negative 1 over 1 plus x quantity squared. So this is the opposite of the function f of x that we have here. All right, so let's see what I need to do then. All right, so I know the power series for 1 over 1 plus x, but I'm going to take the opposite of the power series 1 over x. I could do that later if I wanted, but I'm going to do it now. just to take care of that. That result that I need. Okay, so this is going to be the opposite of, and the power series for 1 over 1 plus x is 1 minus something plus that something squared minus that something cubed plus dot 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 plus. This is the alternating version of the 1 over 1 minus x. Okay, plus dot 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 this. And so from here, excuse me a second. Sorry, I had to fix something for a moment. Now from here, I'm going to differentiate both sides. With respect to x, of course. And over here, I'm going to end up with 1 over 1 plus x quantity squared, as we've already talked about, up here. And so this is our function f of x, by the way. And then if I differentiate this side over here, I'm going to mentally multiply all of this through. So derivative of negative 1 is just 0. Derivative of x is going to be 1. The derivative of negative x squared is going to be minus 2x. The derivative of x cubed would be 3x squared, and then plus dot 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 plus. And then if I imagine this negative being multiplied in here, then this exponent would be n plus 1. Okay, so this is going to be negative 1 to the n plus 1 times n, x to the n minus 1, plus dot dot dot. And there is our power series representation for f. But just to note, on the AP exam, they do like to ask for, oftentimes what you'll see in the question, not all the time, but oftentimes you'll see, give the first 3 terms of the power series, or actually the way they say it is the first 3 non-zero terms of the power series and the nth term. So here's the first 3 non-zero terms. The reason they don't say the first 3 terms, like the first term here technically is 0. We take that derivative of that negative 1. They don't want to see the 0. They want you to see the first 3 non-zero terms, which 1, 2, 3, and the nth term. That's usually what they're checking for this. Okay. The radius of convergence, remember, when you apply differentiation or integration to a power series, the radius of convergence does not change. Okay, you may lose the endpoints in the derivative in differentiating between a power series and then differentiating that power series. You may end up losing an endpoint, just to be clear here. But the radius does not change. Okay, the center doesn't change, and the radius does not change. You just may lose one or more of the endpoints. So the power series for 1 over 1 plus x has a radius of 1, and so this also has a radius of 1. Okay, so in the Desmos activity on the next screen, it says to use the previous screen, the work that we have done up here, to generate a power series for 1 over 1 plus x quantity cubed. It says f of x in the Desmos activity. I'm changing it to g because I have an f up here on the same screen, and I don't want to confuse what I'm referring to by using the same letter. So nonetheless, let's see here. So if I take the derivative with respect to x of 1 over 1 plus x quantity squared, well, what do I get? So a little mental work here. This is 1 plus x quantity to the negative 2. So take the derivative, bring down the negative 2 as a multiplier, and then subtract 1 from the 2, you get a negative 3. I guess I can write that down here so you can see it instead of me just talking about it like this. And then multiply by the derivative of the inner. That's just 1. But that's just negative 2 over 1 plus x quantity cubed. Okay, so that means if I take the derivative of the power series that we generated way back up here, then I'm going to end up with this -2 times the derivative of what I'm looking for. And so I can balance out that -2 with a little simple arithmetic. So let's go ahead and do that. We'll pause and try something with my technology here. Okay, I was trying to figure out if I could cut and paste what I wrote up there, and I was able to. It took me a moment or two, but nonetheless, doesn't matter. All right, so now we're going to differentiate with respect to x right over here. And as we've already shown, that this side becomes -2 over 1 plus x quantity cubed. And if I differentiate over here on the right, I end up with a -2 plus 6x plus, I don't have that next term offhand. Well, I can go back way up here and see where I can get that next term. And so up here, I would have had a negative x to the fourth, so it should be a -4x cubed as the next term here, and -4x cubed. That's going to become minus 12x squared. Excuse me. Okay, plus dot 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 plus -1 to the n plus 1 n times n minus 1 x to the n minus 2 plus dot dot dot. And now to get what I need to get rid of the -2 that's in the numerator, so I just need to divide everything by -2, so I get a 1 minus 3x plus 6x squared plus dot 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 plus -1 to the n plus 1. And then let's see, let's put n times n minus 1 over 2 x to the n minus 2 plus dot dot dot. On the next screen, it says to use this previous relationship to generate a power series for x squared over 1 plus x quantity cubed. And so all we have to do is now just multiply through by x squared. And so we're going to get x squared minus 3x cubed plus 6x to the fourth plus dot 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 plus -1 to the n plus 1 n times n minus 1 over 2 x to the n plus dot dot dot. And there we have that one. Algebra, easy. Now we need to find a power series representation for 5 minus x. All right, so this may be a little confusing for some, and that's okay. That's part of the point. We've got to learn how to think through these sorts of things. This doesn't really look like the other stuff that we have dealt with, but if you think carefully, we know the antiderivative of 1 over 1 plus x would be the natural log of the absolute value of 1 plus x. And that gives us a little bit of a clue of what's going on here. So if I can generate a power series for something that looks like this, which we can, then we can take an antiderivative to get that what we're looking for. So let's move back one step. This was just a little illustration here. Let's move back a step and say, what's the derivative of this expression? Well, the derivative of natural log of 5 minus x is 1 over 5 minus x times -1, or just -1 over 5 minus x. So can I generate a power series for that? Absolutely. If I generate a power series for that, using the earlier stuff that we've been doing, then I can take an antiderivative and get what I'm looking for. All right, so let's work out the algebra for this. So the -1 I'll leave alone for now. I'm going to factor out a 5 and get 1 minus x over 5 here like this. And then you can think of this as -1/5 times 1 over this. I don't really need that parenthesis there. 1 minus, I don't know what I just did there. Excuse me for messing around with this. Minus x over 5. I should have paused the video. Anyway, so this is going to be negative 1/5 times, so 1 over 1 minus something is going to be 1 plus that something. It's not negative. Wow, I got some weird issue going on here. But we'll deal with it. We will deal with it. 1 over something plus 1 plus something plus that something squared plus that something cubed plus dot 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 plus that something to the nth power plus dot dot dot. And so let's not worry about this just yet. Let's do a little bit of the algebra first. You could simplify in one step. Many of you could. Most of you could. Maybe all of you could. But just to be safe, let me not jump the gun here for anybody. And then from here, get negative 1 to... Actually, hold on. No, I want to distribute that. I'm sorry, I'm just noticing that everything's going to be negative here, and that's fine. Let's get negative 1/5 minus x over 5 squared, or x over 25, minus x squared over 125, minus x cubed over 625, minus dot dot dot, minus x to the n over 5 to the n plus 1, minus dot dot dot, since they're all negative. And so this is our negative 1 over 5 minus x. And so now we're going to integrate both sides with respect to x. Integrate with respect to x. And on this side, as we've already worked out, we're going to end up with the natural log of 5 minus x. The absolute value of 5 minus x. And then over here, we're going to get a constant. And then we're going to get minus 1/5 x. Minus, so that's 25, so 1/50th x squared, minus, so I'm going to get an x cubed, I'm going to multiply it by 3, so 1 over 375 x to the third power. And like I said, usually it's the first 3 non-zero terms, and so I'm not even going to do the next one. You can do the arithmetic on that one. And so we're going to end up with x to the n plus 1, 5 to the n plus 1 times n plus 1. This annoying fly right now. It keeps bothering me in the middle of my videos here. Minus dot dot dot. And so there we go. I think the question also wanted the radius of convergence. Well, the radius of convergence is going to be the same. Remember, it doesn't change upon applying derivatives or antiderivatives to the original power series. So if we go back up to this power series here, and we were multiplying through with a common ratio, it's geometric, but with a common ratio of negative x over 5 to get every new term, we need that magnitude to be less than 1. And so that means, absolute value of x over 5 has to be less than 1. So the absolute value of x has to be less than 5. And so just so you know, the center is 0, and this is the radius right over here. So the radius is 5. All right, so now we need to find a power series representation for arctangent of x over 3. Again, this might seem a little confusing at first, but let's go ahead and we're using derivatives and integrals to generate these relationships. And so let's find a derivative of this and see what happens. So it's 1 over 1 plus the input squared times the derivative of the input times 1/3. And so if I work this out a little bit, I get 1 over 1 plus x squared over 9 times 1/3. And so this is going to be 1 over 3 plus x squared over 3. I don't know if I want to... No, actually, I don't even want to do that. I don't want to distribute that. Let's leave it separate like this. I can generate a power series for this expression here, and then multiply by 1/3, and then we could integrate. Okay. So let's write this as 1/3 times 1 over 1 plus x squared over 9. And that's going to be 1/3 times 1 minus something plus that something squared minus that something cubed. It's alternating because we have a sum here instead of a difference. Sorry, I'm trying to do too many things at once. Plus dot 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 plus negative 1 to the n. And then we're going to have this x squared over 9 raised to the nth power plus dot dot dot. And then close that parenthesis. And then, I guess I can do a little bit more arithmetic over here. Squared over 27. And then when I multiply this out, sorry about the noise. I'm going to write this out off recording here. All right, I think my dog stopped barking, so I can get back to talking to you guys through this. All right, so then I just expanded everything. To get this 3 to the 2n plus 1 over here in the last term, just remember I would have 9 to the n in the denominator, which is just 3 squared to the n, or 3 to the 2n. And then the plus 1 comes from distributing the 3 like it was to every single term in that denominator. So that's where that came from. So now I need to integrate both sides with respect to x. And so I already know the antiderivative of this is going to be arctangent of x over 3, because that's how I generated that side anyways. And then I'm going to get a constant of integration. And then 1/3 x minus x cubed over 81 plus x to the 5th over 243 times 5, which is what, 1,000, 1,215. And then do the next one on your own. Minus dot 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 plus negative 1 to the n, x to the 2n plus 1. Over 3 to the 2n plus 1 times 2n plus 1 plus dot dot dot. And there we go. Last but not least for this activity, we want to find the antiderivative of 1 over 1 plus x to the 4th with respect to x using a power series. So, this is one. We'll start with the power series for this part. 1 minus something plus that something squared minus that something cubed plus dot 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 plus negative 1 to the n, that's something to the nth power plus dot dot dot. And then from here, all we're going to do is we're going to integrate. So the integral from 1 over 1 plus x to the 4th with respect to x is going to be a constant of integration plus x minus 1/5 x to the 5th. This is x to the 8th, of course, so it'll be plus 1/9 x to the 9th minus, this is x to the 12th, and so this is going to be 1/13 x to the 13th plus dot 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 plus negative 1 to the n, x to the 4n plus 1 over 4n plus 1 plus dot dot dot. And that's the answer to the last one. Pretty straightforward. I hope this helps. Go study.